All right, we're going to talk about Blue Apron. So is Blue Apron one of those like food delivery like services?
Yeah, it's
Correct.
just like an online kind of deal.
Okay, so Blue Apron. In this challenge, you'll be designing schemas for 3 different applications. So use quick database diagrams to design your schema. There's a bunch of different applications out there to draw out your schema. A lot of these also have like ways to export what you designed into raw SQL, which is kind of nice. Here we're using quick database diagrams. It's up here, but yeah. So it might just, you can literally just take also a piece of paper and like literally draw boxes or like, all right, here's the table name, here are the columns, here's the primary key, and like draw lines as to how those tables are associated with one another. But here we're just going to use quick DB diagrams. It might take a little while to get used to like some of the syntax, but it's relatively straightforward. So I'm going to go ahead and just copy this over Blue Apron. So it looks like, keep in mind, these services have been around for years and you won't have time to design a schema that covers the entire feature set. Your aim is to design a schema that could support the feature set you imagine they launch with, not the one they have today. So it looks like Blue Apron has user, service plans, recipe, promotion. I wonder what promotion might be, and delivery. Let's go ahead and see. So, so I'm just going to bring this over. Can I just bring that up here? All right. So it looks like, what am I looking at? Oh. So we have user, so we can create a user table. Recipe. Is that how it's supposed to? So I'm getting errors there. So it'll be like users. Is this not showing up? So users. Let's just start with one table. Okay, there we go. Cool. So we have a, can I just do that? And it shows up. Users table. Just keep it lowercase. So what should the users table consist of?
I'll say a name or like
Yeah.
their name, obviously probably their address since it's the delivery company, and probably what kind of service they're signing up for.
So let's just try to keep these tables as slim as possible. So again, like we probably shouldn't have address for associated with a user in the users table. We might have a separate addresses table for that. As far as services, can a single user sign up for multiple services? Maybe, maybe not. But yeah, let's just try to keep these as thin as possible. You can do like a prime ID, primary key integer. I think it's like something like that. Or, whoop. Okay. Why am I getting an error there? Integer. Does it go over here? Okay, I guess there we go. Integer. So it's right here. ID, the little key means it's a primary key. Let's just keep it simple. Name. What is it? String. I think. should we keep that? Does Blue Apron like use usernames or anything like that?
You don't have to. You can just do a meals
Name.
per week kind of plan and just pass the money.
All right. So generally users tables also have like a password, maybe a phone number, an email. Those are very standard in like a users table. Name, password, phone, email. All right. What else do we need? Service plans. Service plans. ID. Again, we're going to do primary key. I don't know, plan. Is that a string or maybe that's an ID or something? Where should this be? I think Tim said also like what kind of plan it's on. So
Yes.
here, let's just assume this users table. So service plan ID. Is it a foreign key? Something like that. There we go. I think we do ID. Nope, that's not right. Let's look at that docs. Relationships. So it looks like customer/customer ID. So service plans dot ID. There we go. And this might be just like a one-to-one relationship. But yeah, like it doesn't really matter. I just kind of want to show you like how they're connected. So users have a service plan ID and like the plan. We can also say like amount or cost. I don't know, something, just throwing stuff out there right now. All right. What questions do you have about just these two tables? We have recipe and promotion. All right, so we have recipe. I'm just gonna create the other ones. So what I'm trying to think. Promotion. The idea is to try to get these tables connected in some manner. So if we have a let's talk about promotion. What should a promotion consist of?
Maybe like a % discount.
So ID, primary key, integer. So we can have like, I heard % discount. I'm trying to think.
Promo codes.
Oh, yeah, that makes sense. So a promotion like a code that can be like a string or it can be an integer. A lot of times they're like multiple. It's like July 2021 or something like that. So we can say it's like a string. What else do promotion codes usually?
They usually
have?
have like a duration for someone, like it might be like first 30 days or something like that.
So an expiration date. We can have that to be a date. All right. All right. And what else? I think that might be it for right now. There might be like a join table or that a promotion might like, so this promotion might be attached to like a delivery or something, maybe. I don't know. What else do we have? All right, we have a recipe. Recipes are always fun. So ID, primary key, integer. What else can a recipe have?
It could be
Ingredients.
So a recipe can have ingredients.
A title.
Title, ingredients,
Uh,
serving size. I don't know.
Yeah. So I'm just going to keep it as title right now and have that be a string. I heard someone say ingredients. This is where things kind of get complex. So if I did ingredients, what the hell is going on? Where did that move? I don't even know how to spell it.
Stuff and food.
So ingredients for a recipe. So this is plural ingredients. How would this be stored in the database? Ingredients.
Probably as like a connected table, but for now, a string.
No, I think you're right. It should be a connected table. So ID, primary key. Have int, and then just like name, string. I think that's kind of it. You can also have like,
Probably the amount, maybe like calories and stuff like that. I know a lot of websites do the calorie stuff. They just tell you
right, but like for a specific ingredient, if I had like olive oil, like what would that, like if I put it at like a calorie, like you can also put like, when you said amount, when the amount be associated with the recipe. So if,
I was just referring to the amount of calories. That's all I was referring to.
okay. So that should probably be like a calculation that's done somewhere, maybe on the front end or be stored somewhere else. So we have a recipe that has an idea and a title, and we also have ingredients. So a recipe has a name, but how do we attach both of these?
Would that be like a many-to-many foreign key?
Yep. So in that case, right here, like service plans, we have a one-to-one relationship, and we've also had many-to-one or one-to-many relationships, but we haven't seen a many-to-many relationship. Anytime you have a many-to-many relationship, you have to create a separate table to join those two. And those, so we can have a couple of things. So we can call it recipe ingredients. So we know specifically, hey, that this table is a join table between recipe and ingredients, because a recipe can have many ingredients and an ingredient can belong to many recipes. So like olive oil, I can apply olive oil to, some salad dressing recipe, but I can also apply olive oil to, some steak recipe. And likewise with recipe, obviously a single recipe contains multiple ingredients. So a recipe will have olive oil, have eggs, have, everything, paprika. So that's why we need a many-to-many relationship. So ID, primary key, integer. And here, so now we need a recipe ID, which will be a foreign key to recipes dot ID. Did that not work? foreign key, integer. Where does it go? There we go. So we have that connected to that one. And now ingredients, we'll have to do ingredients. ID, it's a foreign key to what ingredients dot ID. Great. So now those are connected to one another. Can we have anything else on here on the recipe ingredients? This is where we probably have the amount of that ingredient, 1 cup, etc. All right, let's try to, so recipe ingredients. We have promotion and deliveries. Does anybody have any questions about recipe ingredients and many-to-many relationships? And a join table or a reference table?
Would it still be a like one-to-one relationship, or would that be like for ingredient ID? Would that be like a one-to-many in the recipe ingredients table?
Say that one more time.
So, using the syntax of this quick database thing, when you use a dash, that I think means it's a one-to-one.
Oh, yeah. So right there, yeah. And I just literally just do a dash just to get these lines connected.
Gotcha.
Just for like visual, like you can make this. And the reason, so if I made it a many-to-many relationship from a visual standpoint, it probably, I think just in this application, it would create this maybe table for us.
It just changes like the icon at the end of the string to like a little bit of a web looking bastard.
Yeah.
Crow's foot.
All right. So just remember that many-to-many relationships will create a join table or a reference table. And you can literally have, you don't necessarily need in join tables, like a join table can just also just look like something like that. But a lot of cases, join tables have additional information about it. Let's see, promotions, do we have deliveries? What should deliveries contain?
It'll probably have a recipe ingredient attached to it.
So a delivery, so I'm just thinking how this application will work. Yeah.
Probably just a recipe, because a recipe will give all the ingredients.
Yep. So I can have, so an ID, primary key integer, and so let's say recipe
Delivery method.
ID, foreign key, recipe ID.
And then something to tie it to user as well, the user ID.
Yep, that makes sense. So user ID, foreign key, users.id. All right, awesome. Now I like to just try to like make this almost like a map so I can. All right. All right. Promotions. How is promotions connected to any of this?
I would assume the user, because like when you log in to your account, usually that's the promotion is attached to it if you're using it or not.
Although the only place to pay is with service plans. That's the only thing that has cost attached to it.
Yeah, I mean, also maybe a promotion is attached to a single delivery also.
Do you think recipe should have a price that it affects?
So recipe, delivery. Yeah, so service plan. So it's a set dollar per month. It's not it wouldn't be like the service. So a recipe might cost. So yeah, I'm just trying to think. Does Blue Apron charge like a set price per month, or does it fluctuate based off of the recipe you're being delivered that month or that
Yeah,
week? or
it's
something?
it's per month, just like Snap Kitchen is the same way. All it is this whatever plan you have, quote unquote, you just pay for that set month.
Okay. So yeah, yeah. And maybe like a promotion can be applied to a single month. Yeah. So these are like decisions, or like a single delivery. I don't know.
And most of the time, it's like the first like month or two usually.
Okay. So service plans, deliveries. Service plan, deliveries. Yeah. So these are like questions that when architecting or designing the schema that you might want to.
I would think.
Maybe promotions go to service plans just to keep things simple. Or like, hey, at this delivery. So
Now, question for that, because the promotion has an expiration date, but that expiration date should be different for each time it's used.
yeah.
Yeah.
And then that's another question. Can like a user apply for one promotion in 1 month and then that expires and then use another promotion another time? So is it attached to the user? And then is it a many-to-many relationship? Yeah. So these are questions. I think that's what I'm going to do. So I'm going to say like users promotions, users promotion ID, or a primary key integer, users, or user underscore ID, foreign key, users.id, and then promotions ID, foreign key, promotions.id. Because the user can obviously, and then there'd be like some logic where that won't allow a user to have multiple promotions going at the same time. So that could just be logic on your back end. So when a user applies for a promotion, it checks the database. Hey, does the user already have a promotion in the user's promotion? And is that promotion still active? And if it's active, you can't apply another promotion. So this is just the way I'm architecting or designing it. Yours could be totally different. I just wanted to use the tables they gave me and add on any additional tables. So if you look at this, I'm trying to think. So here, technically, you can perform any query, SQL query, and get anywhere. You can grab any data you want from the database. So I can technically start with ingredients and get to promotions. So I can do some crazy complex query that's probably not necessary to grab that, do a join table, grab that recipe, grab the deliveries, grab all the users grab that user that has, or all the users with that recipe ID, and then, grab the user's promotions that they've used and grab that promotion ID.
Question.
Yep.
Is that like the goal is like when you're doing like a schema design, is that you want at least like one kind of connection for foreign key between every single table?
Typically, yes. I don't know of a case. Let's just put it this way. You probably will not be designing a database schema that has a completely separate tables that can't relate to one another, unless they're totally separate applications within the same.
Most likely is helpful here, because that's helpful.
Yeah. So if you ever are designing a database where you have like two totally separate parts of your database where the tables aren't connected in some manner, there's probably a way to make them connected.
Also, like looking at this, like at what point, how do you say like, yes, this is good, this covers all of our bases?
It kind of just depends on what features you want to implement. I would say this is good for right now. And as I'm actually implementing this, and like actually writing the code to,
Okay, so I guess short-term, more personal question for the assessment, so long as it hits all the criteria that was in like here it asked for user promotion, like all the main branches. I guess without us having a front end visually, like if we coded this out in SQL, this would be sufficient because we got all the functioning things and we can query whatever you want us to query, and functionally we can use all that stuff. So for the assessment, that would be good.
yeah. So perhaps maybe during the assessment, you might be given like, hey, make these tables or build this application. And it should probably have a minimum of these tables. And as you're creating these tables, like the schema, you might find out, hey, some of the tables aren't connected. How do I make them connected? That should like kind of point you in the right direction of what additional table you might have to create.
Got it. Thank you.
So I have a question, and I guess it's based on what Andrew's asking because he prompts in my question just because I like his way of thinking. I see that there's well, I'm not going to assume that that's what it is, but to the right of the plus sign, when you can zoom in and zoom out, is that location?
I'm sorry, what are you? Oh, here?
Top right.
So, okay, so move your mouse to the right of that plus sign. Okay, so it says center. Okay.
Oh yeah, just
Gotcha. So with the zooming in and zooming out, could you make depth and then link tables that way?
oh like a Z index
Yes.
on this application, like in this here.
Yes.
I don't think so. I think this is
Okay.
like a two-dimensional representation of your database. I'll say right now, this is a very complex schema, and the assessment won't be as complex as this.
I certainly hope I don't have to write 8 classes for the assessment.
No.
So in like looking at what we're doing for algorithm design and refactoring to make it simpler, as far as this is concerned, is there like a way you'd go about refactoring, making it simpler, or is this kind of, this is, I guess, another dependent thing, but how would you think about like refactoring and simplifying and things like that?
If you find a table, essentially, if you're creating a table and it's got a bunch of columns and like the data in those columns like aren't specifically related to the user, or if maybe you can like separate a single table into 2 separate tables, that's when at that point you'd probably want to create a separate table. But you generally want to keep your tables as slim as possible. Now that doesn't mean a table doesn't have 20 different columns on it, because I've seen in like production databases where a table has got 20 different columns to it, and it should. That's just like the way the table works and all the data that that's associated with that table. But essentially, if you can like right here, if you added on an address to a user, at that point you might want to separate that address to an addresses table. That's pretty standard. But yeah, just try to keep your tables as slim as possible. But yeah, you generally, there isn't a case. There's very rarely a case where it's come up with like, oh, I need to refactor or reconfigure this table, because a lot of this stuff comes in with, a lot of the scenarios come in with actually designing like the schema, like a lot of edge cases. Yep.
as well. Sorry. So I know one of the things that we went over was like this idea of that you shouldn't create, like, you shouldn't put user addresses in the user table. You should create like an addresses table because people could have like theoretically whatever, like the same address.
Mhm.
So we're able to put like email and phone and password all in users because that's all things that only one person would have. Is that correct?
Yeah. Yep.
Okay.
So like if I wanted a separate email, you can actually have like a users table and an accounts table, and like you have like a user and then an account. That might be, and you might like have different attributes or different data on the accounts table than the users table. That's also common. You might see that somewhere.
Okay, but anything that is just gonna only have like one person have it, you can put that on
The users table.
the users table. Okay.
I guess more of a theoretical question here as far as this is all basically how much work you want to do up front versus how much work you want to do up back, right? So like if for say recipes, if instead of going over to ingredients, if you added another column, say ingredients, and had it as an array, that would just have to be input on the front end, or would that like?
There isn't a way to store an array data type in a database or in a Postgres database. So once you start getting that, you're like, okay, in a single column, I have an array. At that point, you're like, oh, I'm storing multiple values in a single column.
I thought I heard something different yesterday.
Okay, you might be able to. Like, I've never seen like an actual data, like an array stored in a column before. That's a good question, but I've never seen it done. And if that's the case, you should probably separate it out into a separate table.
What if you just turned it into a JSON?
Can you store JSON directly into a Postgres database?
I mean, a JSON as a string.
Yeah, and then you're just dealing with strings that you're going to have to parse through instead of just doing a pretty simple SQL query. Any other questions?
Tom, would you mind pushing these up just so we can kind of check out how you have everything laid out as well?
So you want me to take a screenshot of this and post it?
Yeah, if you wouldn't mind.
Yeah, I can post it. All right. With that, let's go ahead and
you can export it.